In this lesson, we're going to go over polynomial arithmetic. Specifically, we'll learn how to add and subtract polynomials, and we'll also learn how to multiply and divide polynomials. First, we'll start off with what is a polynomial. So poly means many, polynomial means consisting of many terms. So below, there's some examples of polynomials: 8x squared minus 4x plus 1, where 8x squared is a term, negative 4x is a term, positive 1 is a term, x minus 5, 7x cubed plus 9x squared minus 5x minus 11, and so on. So when we try to add, or when we're asked to add and subtract polynomials, we have to remember what like terms are, because essentially when you're asked to add and subtract and simplify as much as possible, you'll be able to combine like terms in most cases. So for instance, examples of like terms are 2x squared, and negative 100x squared. The reason these terms are like is because you could add them and subtract them or condense them. We have the variable to the same power in each of these. So even though the number or coefficient in front is different, these are still like terms. Same thing with 3x, x, negative x, and 5x. So just to show you a contrast, things that are not like terms would be 4x, 4x squared, and 4x cubed. Even though the 4's are the same, the variable and the power of the variable or the exponent are not the same. Same thing with the example below, 3x and negative 2. You wouldn't be able to add those or subtract them. Okay, so in order to add and subtract, we have to have like terms. So starting with example 1, being asked to simplify, we have 3x squared plus 2x minus 1, so one polynomial, plus 5x squared minus 8x minus 6, another polynomial. In this case, we're adding the two together. There's no distribution that's required. Sometimes if there's a number in front of the parentheses, you'd have to do that first, following order of operations. But in this case, we can drop the parentheses and keep the problem the same. And then our like terms here are 3x squared and 5x squared, so I'll use the same color, 2x and negative 8x, and then negative 1 and negative 6. So you could rewrite this as 3x squared plus 5x squared plus 2x minus 8x. I'm just putting the like terms together, and then simplify. So we would have 8x squared minus 6x minus 7. And when you're asked to add and simplify, you're asked to get it as small as possible, or make sure that all of the like terms are combined together. In the case of subtraction, we have 5y squared plus 3y minus 1 minus parentheses. Those are really important. Minus, we're subtracting off everything that follows from that minus sign. So we're subtracting 7y squared plus 6y minus 4, or plus 4. So the way I like to think of this is, imagine there's a negative 1 here that we have to distribute to every term. Okay, so what's the first polynomial stays the same, and then this becomes negative 7y squared minus 6y minus 4. Okay, so now that you've taken care of that negative 1 or that subtraction piece, you would do what we did on the last problem, where we would combine like terms. So we'd have negative 2y squared, negative 3y, and negative 5. Okay, so that would be the final answer, negative 2y squared minus 3y minus 5. When it comes to multiplying and dividing polynomials, my tip here for you is to remember the rules of exponents that we've talked about previously. Okay. So multiply, simplify your answer. So you may have learned this as FOIL, where you do first, outside, inside, last. That works when you have two terms in the first parentheses, 2 in the second. Otherwise, think of it as distribution. So I'll go over this one a couple of ways. So first is to use FOIL, where you would multiply the first in each of the parentheses, so 2 times 6 would give us 12. Outside would be the two outside terms, so 2 times negative 3y, which is negative 6y. Inside, 30y, and then our last two terms would be 5y times negative 3y, which is negative 15y squared. Okay, so what you would do is then you would combine all of these to get your final answer. I typically write the powers in descending order, so this would be negative 15y squared. Combining these two is 24y plus 12. Okay. Another way you could do this problem is by setting up a box, and this will work no matter how many terms are in each polynomial. So I'm going to set up my box here, And so this 2 and 5y, so I'm going to put 2, 5y, so I'm essentially separating out the terms. And this is going to be 6 and then negative 3y. So what you do to get each term in the box is you multiply. So for this first box, we would do 2 times 6, which gives us 12. For the box below, 5y times 6 is 30y. 2 times negative 3 is negative 6y. 5y times negative 3y is negative 15y squared. Okay, and then you would do the same thing where you would combine your like terms. Negative 15y squared. This is really plus 30y minus 6y plus 12, and then continue to combine to see that we get the same answer as we did when we did this problem the other way. Okay, you can also think of it as distribution where you would take 2 times 6, 2 times negative 3, 5y times 6, 5y times negative 3y. So there's multiple ways to go about doing this problem. Rewrite without parentheses and simplify. So remember that when something is squared, it means the base is being multiplied by itself. So what this means is that this is x plus 7 times x plus 7. Okay. What this is not, let me change colors here. This does not mean x squared plus 49, where you would just square the x and the 7. You'll get a very different answer by the way we're about to do this problem correctly. So this is rewritten as x plus 7 times x plus 7. You can use one of the methods we just talked about where you use FOIL or the box method. In this case, I'm going to make sure I distribute. So x times x is x squared. X times 7 is 7x. 7 times x is also 7x. And 7 times 7 is 49. So then when you combine like terms, we get x squared plus 14x plus 49, which is very different than just x squared plus 49. So make sure you're aware of that when you're asked to square these. Okay, example number 3, our last example. Divide and simplify your answer as much as possible. So for this problem, what I would recommend is splitting up the numerator and leaving it over the same denominator, and I'll show you what that looks like. One thing is we have negative x squared on the bottom. If you're more comfortable, if you don't see a number in front, you can put a 1 there, okay? So this can be rewritten as 5x to the 7th divided by negative 1x squared. I'm going to keep addition in between and just keep my signs. Okay, and so now you divide. So now we're working with each term separately. So you divide the numbers. 5 divided by negative 1 is negative 5. And x to the 7th over x squared is x to the 5th. You subtract the exponents, or you can write them all out and see what cancels. Plus, negative 4 divided by negative 1 is a positive 4. X to the 4th over x squared is x squared. Not because 4 divided by 2 is 2, but because 4 minus 2 is 2. And then for this last one, 2 divided by negative 1 is negative 2. X squared and x squared cancel out. So just the negative 2 stays as a constant. Thank you for watching. If you have any questions, please feel free to reach out to me.